Okay, so let's move on to example number 3. So for example number 3, which is the last soil weight and volume relationship problem in this set, it's really important to be very good at the phase relationship. I encourage you to at least to find 10 to 15 similar problems and to really practice on this topic. It would not only help you perform better in the exam, but also save you a lot of time during the exam. So let's look at this example number 3 together. We have a soil with a void ratio of 0.41, and we know the unit weight of the solids is 33 kilonewton per cubic meter. And the question is asking for the saturated unit weight of the soil. As usual, you can pause the video for about 2 minutes and work on the problem, and we'll be back. Okay, now we're back. So first of all, let's try to summarize all the givens. We have the void ratio is 0.41. We have the gamma S is 33 kilonewton per cubic meter. And the ask is gamma SAT. Okay, to start with, let's have a quick refresh on all the definitions of all the 3 parameters. The first one, void ratio, is V sub V over V sub S, the volume of the voids over the volume of the solids. The definition of gamma S is the weight of the solid over the weight of the solids. So this one is a little bit tricky, but remember, we're talking about the solids only. Definition of gamma SAT is the total weight when soil is saturated and over the total volume. Okay, let's try to plot the 3 phase again. And for this problem here, we're talking about the soil is saturated. So we actually only have 2 phase, that is just the water and the solid. And we can start from the volume side and gradually go to the weight side. Because we already know the void ratio, and so it's a good idea to assume the weight of the volume of the solid is 1. We're talking about metric system here. We're going to go with 1 cubic meter. So if the volume of the solid is 1 cubic meter, then the volume of the water is the same as the volume of the voids, because the soil is fully saturated, and then that would be 0.41 times 1 cubic meter. Then you would have 0.41 cubic meter. So basically everything on the volume side has already been figured out. Let's try to move on to the weight side. So based on the definition of gamma S, and we already know the volume of the solid, so the weight of the solid is pretty easy to figure out. So weight of the solid would be 33 kilonewton per cubic meter times 1 cubic meter. So we have 33 kilonewton. So we have 33 over here. So weight of the water is also pretty easy because we already know the volume of the water is 0.41. And if you would recall the unit weight of the water in kilonewton per cubic meters, that would be 9.8 kilonewton per cubic meter times 0.41 cubic meter. And this would give us about 4.0 kilonewton. So we have 4.0 in the top for the water, and we have 33 kilonewton for the solid. And with that, then the total weight, which is the summation of the weight of the solid and the weight of the water, we're looking at about 27 kilonewton. So now we have the total volume, we have the total weight and the total volume. Your gamma SAT is 37 kilonewton over 1.41 cubic meter, and the final answer is about 26. It's actually about 26.2. The nearest number would be 26. So the correct answer is C. So, yep, that's pretty much about it for example number 3.